Okay, so we will talk about how it's never been easier to write TLA plus tooling. We're going to talk about some work funded by the TLA Plus Foundation to make it easier to both contribute to the core TLA Plus tools and to develop your own TLA Plus tools. The thesis underlying this talk is that everything we want to do is downstream of making it easy to develop TLA Plus language tooling. So here's the outline of the talk. We're going to talk about what actual TLA Plus language tooling exists at this time. We're going to talk about overcoming what I'll call the legacy code challenge, not really mysterious what that is. And then we're going to talk about what could be next for TLA Plus language tooling, both immediately and in the moderately near future. So for existing tools, let's talk about parsers. Parsers are going to be the absolute foundation of any TLA Plus language tooling, because of course, if you're writing a program to deal with TLA Plus, the program needs to know what the TLA Plus says. So here are all the parsers that exist. We actually have a pretty good stable of them. Of course, we have SANI, which means Syntactic Analyzer. This is our flagship parser. It's in the core Java tools. It is a recursive descent parser written in Java. It's actually a generated parser by something called Java CC. It's a Java parser generator. It is the only really full-featured TLA plus parser in existence. It handles all the syntax. It does something called level checking. It's the only thing currently that really does level checking. And it also runs a whole bunch of semantic checks, which are sort of unique to it. So if you're looking to build some language tooling, that's probably your best bet, unless you kind of have specialized or reduced needs. The next up is the TLA PM. The TLA Proof Manager actually has its own parser. It is a parser combinator parser written in OCaml. It doesn't really handle all the syntax, doesn't handle like recursive operators. It doesn't really do many semantic checks. It also has a very minimal level checker that doesn't check too many things. But it is still usable for some things, especially if you're working in the OCaml, what you would, I don't know, like if you're using OCaml essentially. Next up is the tree sitter grammar. I presented this at this conference in 2021. That is an LR1 parser, if you know what that is. It gives us nice static analysis of how ambiguous the language is. So if you want to add anything to TLA plus language syntax, it's really good to prototype it in there, and it will tell you how ambiguous you made the language. Like for example, Marcus was suggesting using pipes around a set to be like the set size, and we prototyped that in the tree sitter grammar, and it said that it would make it horrifically ambiguous, so we decided not to do that, which sucks because it'd be really nice syntax, but whatever. Yeah, so this is sort of like, it generates C code and also some handwritten C. This makes it very portable. It has a lot of bindings in different languages. There's Python bindings, there's Golang bindings, there's JavaScript bindings, there's Rust bindings. So actually, this is a pretty good solution for if you want to write some like lightweight language tool that doesn't really require semantic analysis, just like purely syntax based. Then those are like I'd say like the three main ones, and there's like some others floating around. So there's one recently released by Ioannis Philippidis, who is best known for some work on TLA PM. It's written in Python. You can find it at that link. And there's also Decal, or now renamed to Forja.
Sorry, correction.
Yes.
The one that exists is actually Pigo. It is still the same source tree. The Decal
Okay.
thing and Forja is a next-gen thing that is
Sure.
different in any case and not the Pigo thing.
Okay, but that is the thing that has the TLA plus parser sort of that you're writing, right? As an example.
The new one, and Pigo is the one that exists and you can actually use it.
Sure. Okay, so there's that in some sense. There's also a few like random ones floating around. Like there's a Haskell one I found on GitHub. I also got halfway through writing a Rust one. It's not really what anyway. So that's what you have as your foundation. Now let's go up one level in the stack. Let's talk about interpreters. For the longest time, we had one TLA plus interpreter in existence. That was the TLC interpreter. TLC stands for Temporal Logic Checker. Now, as was presented last year by Will Schultz, we have two. There is Spectacle, previously known as TLA Web, that actually he implemented a TLA plus interpreter, which is pretty amazing. It's written in JavaScript. It runs in the browser. It actually uses the tree sitter grammar. It uses the JavaScript bindings to the tree sitter grammar. And it's really fun. You can choose your path through state space. I think like many of us here have probably seen it. So again, going up the stack. What about model checkers? There's, of course, TLC. Everyone knows this is the flagship model checker, finite state. It is, again, similar to Sani. It is the only one that's like kind of fully featured. It handles all liveness and all refinement. I don't think any of the other model checkers handle refinement. Refinement's kind of like a banner TLA plus language feature, so that's pretty important. There's Appalachi, symbolic model checker, written in Scala. It also uses Sani for parsing because it's in the JVM ecosystem. And it can do some liveness checking, but not refinement. And then finally, there's Spectacle. Actually, Spectacle recently was updated to just add safety checking. It can just do like a breadth first search through your state space. Once you have an interpreter, it's not too hard to do, just like turn it into a model checker. It's just you write breadth first search, right? And so, yeah, you can just check safety properties in the browser, which is pretty cool. Now, here's just a grab bag of all the other, not all the other tools, just like highlight ones. TLAPM, of course, the proof checker has OCaml translating TLA plus code back to backend provers like Isabelle, Z3, Xenon. There's Snowcat, a type checker. I think this is underused, actually. I think more people could maybe look at using Snowcat and adding type annotations to their specs. I plan to do that. Marcus doesn't really agree. He doesn't like this. But I like type annotations. I think they're cool. This is integrated with Appalachi. We have not one, but two now TLA plus formatters. This is pretty recent. There's TLA+-formatter written by Federico Ponzi, which uses Sani for parsing. And there's TLA format by Dom Dwyer, which is written in Rust and uses the tree store grammar. So that's pretty cool. We also have a language server implementation now. This is another recent thing. Probably many will not have heard of this. Karolis Petrauskas has been doing a lot of work on TLAPM, and he used the TLAPM parser to write a language server implementation in OCaml that's primarily focused on making proofs supported in the VS Code extension. That's like his big aim. There's TLOC, which I presented at 2021 as part of, no, 2023 as part of my like Unicode work. It converts your spec between Unicode and ASCII, which everyone should start using Unicode. Use it. It's great. And that's written in Rust, uses the tree sitter grammar. Final one I'll talk about is the TLS VS Code extension. Yes?
No, just wanted to answer since you called me out explicitly. I'm all in favor of type checking, but this particular type checker makes you distinguish between sequences, records, and functions.
That's true.
And that fundamentally is incompatible with TLA plus and how functions are defined in TLA plus. And that makes it a hassle to use.
There is some difficulty there because TLA plus is the weird thing where like a function is also a sequence, and
that's not a weird thing.
It's a bit weird.
No.
Okay.
Right.
Yeah.
That's the real thing. The type checker is wrong.
Okay, the type checker is wrong.
Type checker is wrong.
Okay, type checker is wrong. And then finally, there's the TLA plus VS Code extension, which hilariously uses regular expressions to parse TLA plus. Not very well, whatever. It works more or less well for its purposes, I guess. Okay, so in summary, what did we learn here? We learned that the ecosystem is actually fairly healthy. There's like a decent amount of movement here. There's clear community interest in improving TLA plus language tooling. People just don't want to just use TLA plus, they actually want to make it better. I think that's really good, inspiring. That's a good energy to have in the community. All right, so now let's move on to the second phase here. We're gonna talk about the legacy code challenge. I think many people have probably read this book, Working Effectively with Legacy Code. It has a really nice, concise definition of legacy code that I like, which is that legacy code is code without tests. This is a good, objective definition. I've come to think of it also in a kind of more softer, wooey type way, which is that it's like legacy code is code that isn't in living knowledge. Like it doesn't exist in its totality in the heads of the people that work on it. And the thesis of the second section is that we must overcome this legacy code challenge, which I'll talk about how that applies to what we have. If TLA plus is to thrive, like it's fine to just like trundle along as it is, but if it really is to thrive, we need to overcome some challenges, and I'm going to talk about that. Also, the thing that relates this living knowledge definition to the testing definition is that I think you can only really develop this living knowledge if you are able to write tests for your code and like poke and prod it and see how it flows and moves and everything like that. So tests are a precondition of developing this living knowledge. Okay, so let's talk about how we're actually encountering this legacy code challenge right now. So Sani and TLC, that's like kind of the focus of this section here, although I'll mention other things. They were written in Java over 25 years ago. And then they were modified pretty extensively for TLA plus version 2 around 10 years ago. No original authors are still with the project. So we have like Yuan Yu, I think, wrote TLC back in like late 90s. Marcus has been with the project for a while and is the originator of like a decent amount of code, but it is not like the original author of it, right? And so you have things like the liveness checker, which is very difficult to understand. Like I think Marcus is the only person who ever dares to like try to fix liveness checker issues. There's a lot of global static state that makes it hard to test. Recalling from the previous slide that we need to be able to test things in order to build this living knowledge. And since all the original authors have left, we are in the case of like, we have to basically get this living knowledge back. There's like large sections of the code base. We don't know how they work. We don't feel safe modifying them. And that's not a good place to be. Next, I'll also briefly talk about TLA PM. This is a much, much more difficult problem. I think that's like, this is an entire talk in itself. I was talking with Marcus a bit about this. Like, it is so much more difficult to understand as a project than TLC, which like is kind of just like breadth first search mostly. Like most of us know how breadth first, like we can kind of picture how what TLC is doing when it's doing its thing. But like TLA PM, you have to know very, very particularly what the semantics of like the temporal logic of actions are so that you can translate the syntax to these different backend provers like Isabelle, Z3, all this stuff. You're basically talking like PhD level type things. And so TLPM came out of like an INRIA MSR collaboration about 10 years ago. The funding for that has lapsed. And so the development hasn't really exactly halted, but it's like really ground to a halt. Well, it's really slowed down a lot. And it's a very, very interesting question how we could like restart TLAPM development and like even come close to building that living knowledge of how it works in like a way that doesn't just require us to like continually hire a postdoc that will then just like leave and all their living knowledge leaves. We'll also talk about Appalachie. Appalachie was developed by Informal Systems and it was recently spun out. So it doesn't really have much development going on now. The foundation has not adopted it officially, but it is it's a cool tool. I mean, I think like it deserves to be maintained and it's an interesting question how we could also go about bringing knowledge of that. But anyway, I'm going to focus on Sunny and Tilty. But I think it's good to think about how we can handle all of these things because we have like quite a lot of code lying around that not a lot of people know how it works, and we need to wrangle it if we want TLA Plus to thrive. Okay, so here's the dream. This is what I want. This is the number one thing that I want for TLA Plus. It is a world we are bold and unafraid to make large changes to the core TLA Plus tools, right? We just go in there, we can change things, add features, fix things, make it more usable. We don't need to worry about breaking a bunch of stuff. So how do we get there? First of all, we should count our blessings. Language tooling is one of the few areas of software engineering that is honestly kind of tractable for this because specifications for what your program should do are relatively complete and unambiguous. Like you can honestly complete a parser, which is not really a thing you can do in any other area of software almost. Like most of the time, if you're starting a project, you're like, I'm going to be maintaining this forever, right? Versus with language tooling, you can actually get to a state where you call it done. So that's great. So we're starting off from a really strong position here. And then we have testing. This is going to be where I'm talking about what I've done with the TLA Plus Foundation funding. The TLA Plus Foundation is being given me some stipend for the past like 6-7 months, and I've been doing a fair bit with it. Primarily dealing with testing. So we have the TLA Plus examples repo, which is a really nice set of end-to-end tests. I kind of did that before coming into the funding, but then here's what they've been funding me to do. We have this very large corpus of syntax inputs and expected parse tree outputs. I've been extending that to apply it to the TLA PM tools and also just like extending the number of tests in there. So now tree sitter grammar, Stanny, and the TLA PM parser all use this exact same corpus. So we have like a nice sense of conformance between all of them. I developed this semantic level corpus. So you have a bunch of things like assertions, like this expression has this level, where it's like constant, variable, temporal level, or action level. Or like this variable refers to this thing. It's just like a whole bunch of assertions like that that try to explore the entire syntax. And a big recent thing I did also is developing the flip side of that, which is the semantic error corpus. This is about 150 different little parse inputs that should each trigger a unique error in any TLA plus parser. So like this, I don't know, just referring to a variable that doesn't exist, double priming a variable, like things like that should all be caught. And this is a really nice error corpus to have. Especially because it's like totally implementation agnostic. Like it's just tiny little TLA plus snippets that you can give to any parser, and then you can check whether it is conformant or not. So spoiler, we took all of this and put it to the TLAPM parser. The TLAPM parser does not do very well on it. And so we're probably going to replace the TLAPM parser with Sani is the plan for the near future. So it'll go on its way. We can talk about onboarding new code contributors. This is this is one that's getting kind of closer to my heart. I really like writing tutorials, explanations, things of this nature. The foundation funded me to write some contributing, developing docs for all the major repos. I've been writing these like monthly blog posts. I don't know if you've seen them. It's like development that has been happening the past month. In every blog post, I also highlight a good first issue, kind of, which we've developed like a good stable of them, like 5 or 6 at this point, and I just kind of write about why they're a good first issue, like where you could get started on it. So that's really good. Tutorials, not just documentation. It's like not enough to just have documentation of like what each class does. You have to be like, if you were starting out from zero, here's your tutorial about like how to start developing in this code base. And that's what I'm going to talk about in the next slide. I've been spending a lot of time on that. Final thing, type ins from the TLA Plus Foundation. The fundamental contradiction of free and open source software is that a project that's like a real open source project requires full-time commitment. It's not like a nice evenings and weekends thing. When I first got in this game, I was like, oh yeah, Linux, you know, it's just like people developing on their evenings and weekends. Not true at all. Thousands of people, maybe hundreds, develop Linux like full-time. And that's a contradiction because people need to eat. And how do you get money if you're giving something away for free? So there are a lot of ways of squaring that circle. One of them is having a foundation that gives you a stipend. That's what I've been doing for the past 6 months. So I'm living the dream. Other people can live the dream as well. If we can get another person or two on a stipend, just developing this full time, I mean, being paid to work on open source is a pretty blessed existence. So I think that it's very, very good. Without the foundation, TLA Plus, I don't think has much of a future. Okay, I said I was going to talk more about tutorials. Building your own TLA Plus tools. So I have been writing a tutorial series on writing your own model checker for a very simple subset of the TLA Plus language. You got to know how to write a parser if you're going to work on the parser. That's my thesis. And you got to know how to write these things if you're going to modify these things. There's this website, codecrafters.io. I don't know if you've heard of it. They're like pretty well known for like making a write your own SQLite, write your own Redis and stuff. I think this type of tutorial is like really cool, where you write just like a very simple version of the thing that you're going to work on. It gives you such like a nice, strong mental model of like where the hard parts are. So I've been writing that. You can go to this link and you can see a tutorial that is like not entirely complete at this point, but it's like pretty far. If you were to start following the tutorial now, it'd probably be done by the time you catch up to where the tutorial currently ends. It follows this book called Crafting Interpreters by Robert Nystrom. It's a really, really good textbook. It's kind of just a TLA Plus themed wrapper around the book. I'm really happy this book exists. It's free, it's online. If I had to come up with this material from scratch, it would take me years, but this book is amazing. I can't honestly say enough good things about it. So this is, I think, the boot camp for if someone wants to contribute to the TLA Plus tools. First, they go through this tutorial, unless they have like already really strong background in all this stuff. And I think that I've tried to compress everything I know about parsing TLA Plus, which is quite a lot, into this tutorial. You learn how to parse conjunction and disjunction lists, which is probably like the apex, I don't know what you say, linchpin of the tutorial, which is the most difficult part of parsing TLA Plus. And anyway, yeah, give it a look. Give it a look. Okay, so let's talk about this. What did we learn about this challenge? First, it is fundamentally surmountable. We like to think that we're not exactly a programming language in the TLA Plus community, but we have the same challenges as all the other programming languages out there. And a lot of them are a lot more complicated than us, really. They are. Like they have debuggers. I mean, we have a debugger now, but you know, like there's a whole. I do think that they're more complicated. A lot of like they have to generate actually like machine code and stuff like that. Anyway, um, and like even the exotic stuff in TLA plus, like the liveness checker, it's like just algorithms. I found coming out of university that like algorithms are the easy thing to learn, and the really hard thing to learn is how to function in a large code base where you don't know how it all works. Versus like a function is just like some instructions, and you can like learn how it works, and it's fun to learn. So yeah, it like liveness checking is just a graph algorithm. You can learn how it works. Really, not even probably like in a few days if someone wrote the right tutorial. So this is all tractable. TLAPM probably a bit less tractable, but at least for TLC, it is tractable. Everyone here could develop TLC. It's not like some weird, crazy PhD thing. Okay. All right, so let's talk about now what I think could be next in the immediate future. One is that I've spent a bunch of time, and the foundation has spent a bunch of money paying me to develop all these test corpora. And it's all fine and well for me to be sitting there like plugging away, like manually making all of these tests, but what if we could generate them? And so I write a program that generates like a semantically valid spec, and we check that the parser can handle that, or like a slightly semantically invalid spec, and we check that the parser rejects that, or we generate like a random state space, and we generate a spec that generates that state space, and then make sure that it satisfies some liveness property. Things of this nature. I think that this is probably the future now that we have this like core bunch of tests that can like handle like the stuff that we need to be correct, and then we can start exploring like the corners of the language kind of randomly. It's also a lot more fun to write in a program like this than to write a test case. Like honestly, writing these test cases, like it was a bit life crushing. But anyway. Syntax simplifications, contentious topic. I am an odd person in that I actually like the TLA plus syntax. I like it quite a lot. I even like it. I like it even better in its like Unicode form. But I mean, among this selected group, we probably also are more likely to like TLA plus syntax than your average person. But if Hillel Wayne were here, he is not. He's currently getting married, bless him. He would tell you that among the people that he teaches TLA plus, there's like a lot of things that they commonly find confusing. For example, set filter and set map. There's no strong disambiguation between that now. It's like what side of the colon the generator is on. There's an RFC right now where we could use like keywords like maps or something like that. So things like that nature. Or people get confused by conjunction and disjunction. It's like an up arrow versus down arrow. Like I'm not really sure how we could modify the syntax in a way, like would it literally just be like the and word or something? But like things like that, right? I'm open to ideas here. I'm not like totally married to the syntax, although I do like it. I do think that we possibly could improve it. Here's another thing. All caps keywords. Nobody's made a language with all caps keywords since the 1980s, except for like TLA plus. I would be fine with going to lowercase keywords. That would be like a basic thing. On the other hand, we could say, you know what, like TLA plus should stay TLA plus. We have these other languages like Quint or like FISB or like P, and they can explore the sort of like more programmer-friendly syntax. We should stay, that's also another possibility. I'm not too stressed about this either way. Like I said, I like the syntax. One other thing is the Sani API and consumption experience. I've been working on this lately. The foundation's also been funding me for that. They didn't know it, but they have been. So Calvin's been helping me design a new API for the Sani parser, just to try to make it easier to consume by tools. Right now, all the unit tests now for Sani actually use this updated API. So that's how we're like exercising it before releasing it to the wild. Also, Marcus has been working on packaging it. And so we have like all the nightly snapshots are now uploaded to to the package manager store, and you can download them, use them. Calvin's also be working on something cool. There's this thing called Graal VM. If you hate the Java virtual machine and like hate having to install Java to use the TLA plus tools, we can have graalvm builds, which basically takes Java and compiles it to this like self-contained native executable, where you don't have to pay like the JVM startup time and stuff, and then you could use it in your project without requiring that the user install Java. I think that's pretty cool. Okay, and then there's one last thing. I'm going to end this with a bang. A bold initiative. Increase the TLC model checker throughput to 1 billion states per minute by using a bytecode interpreter. Back in Murat's talk, we saw on the slide that TLC roughly clocks at about 1 million states a minute. I think it was like 8 million states they got with 10 minutes of model checking time. What if they had, you know, like 10 billion states with 10 minutes of model checking time? They might be able to go from like 2 transactions to 3 transactions, honestly. So, you know, but maybe there'd be a bug hiding out in 3 transactions that they wouldn't find in a set of 2 transactions. But I do think this is possible. Calvin's done some like very basic prototyping of basically automatically translating a simple TLA plus spec to just like C++ and then compiling that as like a program to run. Other model checkers like Spin do this. Marcus said that this starts out well, but then hits scaling limits. I think that's probably true. But anyway, yeah, I think this is a worthwhile initiative that maybe we should like aim high. I think we can speed it up a lot. Okay, so hopefully you've learned and have been convinced that this is a great time to develop TLA plus language tooling. There's new tests that have given us a lot of visibility in the code base, so you should feel bold to make changes in it, at least for the parser. And the foundation's been funding this work, and we're grateful to them. So yeah, that's the end of the talk. Any questions?
Then I start with one. Which one of these various directions have been funded by the foundation?
None of them have been funded.
Sponsored.
Oh, sponsored. So none of them have really been funded. When I talked about generative testing to Stefan and Chris, they were interested in that. But the immediate future thing that I'm going to be working on, in addition to this tutorial, is taking TLAPM and switching it to Usani, which has been the goal for a while. And that's actually been kind of like the purpose of these various tests, is to like really nail down like what the parser behavior is before we like switch all these parsers around. So that's like the one thing. But I think after that, probably generative testing is on the docket. It would be nice to also like do some like little tiny syntax simplifications. Like I think that those would be pretty easy to do. And those are more like, there's probably more like debate involved in that than the actual like code changes, you know? But yeah, none of that's been like this has not been approved by the foundation, I should say. But I think I could probably make a decent case for it.
Just wondering, in your opinion and other people's opinion, which of these directions would bring in the most people into the community in terms of increasing the user base?
In terms of increasing the user base, by the way, I just figured out what the echo is like the speakers on my laptop going on. Anyway, in terms of increasing the user base, I think that I do think a combination of simplifying the syntax, and there is a lot of TLA plus learning material, but I think we haven't hit what I think of as like the holy grail, not really a holy grail, but like, I don't know if you've ever played the natural number game with Lean. It's like a web-based series of tiny little exercises, tiny little puzzles that like each you solve and you get this little like dopamine hit and you go like the next level. Like I want that for TLA plus. And so we need a few things for that. One is that we need a web-based interpreter, which Will wrote Spectacle, but doesn't quite work because it uses my tree sitter grammar, which does not give parse error messages. So that's not good for beginners. And so I need to think about how we can get there. Like, Hillel Wayne is currently developing a set of exercises for TLA plus, which is great, but they are still fundamentally like you have to run them locally. And maybe that's okay. Like I did the Rustlings exercise course, and that really helped me learn Rust, for example. It really sold me on the idea of these like tiny little puzzles. Same with like the natural number game. And so I think like, to get back to your original question, I think like a tutorial like that in addition to like syntax simplification, I think will improve like getting new people in the community as users. As far as getting new people in the community as developers, definitely stipends and the tutorial, I think, are the two things, probably. Yeah.
It has long frustrated me that the documentation is published the way that it is.
Yes.
Is turning it into the sort of documentation that modern programming languages have on your list or anybody's list of things to do / fund?
I would like that. I try to think about like where I would put this in. Like, I mean, like I definitely like enjoy writing technical documentation. Would the foundation fund me to do that, or like they want to do something else is the question. So this tutorial that I'm writing, it's on docs.tlapl.us, which is this wiki that Federico Ponzi set up. And that is, I don't know if we've like 100% committed to that being the place where the documentation is going to go. I mean, it's going to be a matter of like, is that the place where the documentation is, right? Like, if, yeah, I would like you for there to be like simple documentation that's not in PDFs. Because every time I open a PDF to like search for the thing that I want to search for, which is fairly often, it's like, I hate it. Yeah.
Right, it's also published often in conferences at a specific moment, and it's not clear how outdated it is or where to find the updated version.
Yes. I think there needs to be a canonical living document that like is updated as the language is updated. If we're talking about like language changes, like syntax changes, for example. Yeah.
Not a question, but you'll just make me think of this with your exchange. It took me about 2.5 years to realize that TLA plus 2 existed. I was writing dev tools the entire time.
Maybe it also.
It's the
doesn't really
proof
matter,
language. The TLA plus 2 is when the proof language was added. And they added also recursive operators. They also changed the way that referring to operators in like imported modules works.
You've always been using TLA Plus version 2.
Yeah.
Okay, then, thank you, Andrew. More time.